This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 5 of Week 6, Supportive Knowledge. Pipe and pressure vessel stress. Internal pressure loads a cylinder's wall in two directions at once, and the handbook gets closed forms for both when the wall is thin. We meet hoop and longitudinal stress, the 10-to-1 thin wall test, the wall sizing formula with allowable stress and weld efficiency, and finish with one clean hoop stress problem. Pressurize a closed cylinder, and the wall carries two stresses at once. Hoop stress wraps around the circumference. Longitudinal stress runs along the axis. When the wall is thin, diameter over thickness above 10, hoop is PD over 2T, and longitudinal is PD over 4T. Notice the factor. Hoop is exactly twice longitudinal, so the circumferential direction always governs. That is why a cylinder fails by splitting lengthwise. Hoop stress is what pulls a longitudinal seam apart, so the axial joint is the critical one, and girth joints see only half the stress. The handbook writes the same pair a second time in radius form. PR over T for hoop, PR over 2T for longitudinal, using the inside radius. Identical equations, since diameter is twice radius. Memorize one form and know which one you hold. A sphere has no unique axis, so hoop and longitudinal collapse into a single stress, PR over 2T, the same in every direction. That matches the cylinder's smaller stress. A sphere is the most efficient pressure container, which is why cylindrical vessels get dome-shaped ends. When the wall is not thin, D over T at 10 or below, the closed forms lose their license. The handbook tabulates the thick wall stresses at the inner and outer surfaces. They vary through the wall, and the governing tangential stress peaks at the inner surface. For design, the wall thickness comes straight from the code allowable, PR over the quantity SE minus 0.6 P. S is the allowable code stress, strength already divided by the code's factor of safety, and E is the weld joint efficiency, a penalty on the seam. Where those numbers come from is the next topic. And flip the hoop equation around and you get Barlow's formula. The maximum working pressure of a pipe is 2ST over D. 3 formulas, 1 idea. Pick the one whose unknown matches the question. The notation. Hoop and longitudinal stress are the two outputs, and hoop always governs. Pressure, diameter or inside radius, and wall thickness are the 3 inputs, with D over T as the thin wall gate. S and E enter only when a code sets the allowable. Everything stays in PSI and inches, no conversion constants anywhere. So the only unit job is keeping the two lengths in the same unit. Burked problem. A steel pipe at 600 PSI gauge, inside diameter 20 inches, wall thickness ½ an inch. First verify the thin wall equations apply. Then find the hoop stress and the longitudinal stress. Here is the cross-section, pressure pushing outward on the ring, hoop stress carrying it around the circumference. Check thin wall first. D over T is 40, comfortably past 10, so the closed forms apply. Hoop stress is PD over 2T, 12,000. Longitudinal is PD over 4T, 6,000, half of hoop. Cross-check with the radius form. PR over T with a 10-inch radius gives the same 12,000. Hoop governs. That 12 KSI is the number you would compare against the allowable. Notice the lever arm. A 600 PSI line turns into a 12,000 PSI wall stress because stress scales with D over T. 4 traps. 1. Radius versus diameter. PD over 2T and PR over T are the same hoop equation. Mix the forms and you are off by a factor of 2. 2. The thin wall forms are only licensed when D over T clears 10. Below that, use the thick wall table and expect the peak at the inner surface. 3. The wall feels the pressure difference across it, so with atmosphere outside, use gauge pressure. Adding atmospheric inflates every stress. 4. Keep the units consistent. Pressure in PSI with both lengths in inches lands in PSI, and make sure the answer and the allowable are in the same unit before you compare. Bookmark 1-page pair. The pressure vessel section, the thick wall table, the wall sizing formula with allowable stress and weld efficiency. Then the thin wall forms with the D/T test and Barlow's formula. Overleaf, the radius forms, and the spherical tank result. On exam day, run the thin wall test first. Pick the formula whose unknown matches the question. And remember, hoop governs. You can now take a pressurized pipe or vessel from geometry to stress. Run the thin wall test. Apply PD/2T and PD/4T. Cross-check in radius form and size a wall from the code allowable. Today's 20-inch pipe at 600 psi carried 12 ksi of hoop stress, double its longitudinal, and the number a code would judge. But we treated the allowable stress and the weld efficiency as given. In Topic 6, we open the documents that set them, the ASME B31 piping codes and the boiler and pressure vessel code. Same formulas, now with the legal numbers.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.